Okay, let's start with experiment 5, that is Muller's method. Muller's method. So far, we have been discussing several approaches to find the root of polynomials. Okay, so root of polynomials. We have already seen several approaches, 4 or 5. Okay, so this is another method to find the root. So before getting to this thing, let's discuss a little bit about polynomials first. Okay, polynomials. For example, if I put a curve like this, say for example this is my x and this is my y. Okay, so if I draw a curve like this, like okay, one straight line. Okay, so this is a straight line, and you know the equation of the straight line is y is equals to mx plus c, mx plus c. Okay, so this means that this equation, a straight line has two parameters. Okay, one is the m, that is the slope, and c is the this portion. This is the portion that is crossing in the y-axis, and m is the slope, that is the tan theta. Okay, now this is known as a first degree polynomial. This is first degree polynomial. The first degree polynomial has a straight line. Okay, the shape of it is a straight line, and you know the equation. Okay. Now if we go into higher, say for example second degree polynomial, like second degree. So what is the equation of the second degree polynomial? It is like y is equals to, this is the general form of equation, ax square plus bx plus c. Okay, x square plus bx plus c. So it is second degree because I have the highest power of x is 2. Okay, so the maximum power of x, this is the maximum, this the power is 1 here. Okay, and here the power is 0. The highest power is 2, that's why it is second degree. It is also known as the order of the polynomial. Okay, order. So order, this equation has order of 2. Okay, and it is a second degree polynomial. So how should the curve look like of second degree polynomial? When I have something like this, okay, the curve is no longer a straight line. So the curve is like non-linear curve. It can be this shape, okay, any shape, but non-linear curve. Okay, a curved line. So this is no longer a straight line, this is now a curved line. Curved line. Now what about higher degree? Say for example third degree polynomial. Third degree. So third degree means the maximum power y is equals to, it will be like ax cube, okay, plus bx square, okay, plus cx plus d. Okay, so maximum power is 3. So this is a third degree polynomial. Okay, so how should the curve look like for these things? Okay, say for example the curve can look like this. Okay, now from third degree it can be even higher degree, fourth degree, fifth degree, sixth degree polynomial, something like that. So the difference is, when you have a straight line for first degree polynomial, that's a pure straight line. Okay, so a straight line means there are no peaks. Okay, no peaks or valleys. So what is peaks or valleys? Okay, let's come here. In the second degree you have maximum one peak or one valley. Okay, in a second degree polynomial one peak or one valley. Okay, and for third degree polynomial there will be multiple peaks and valleys. Peaks and valleys. Okay, so what does they mean? This is for 2 and this is for 3. Now as you can see in the curve, say for example this curve, this one is called a peak. Okay, this is a peak point, the highest point, top of the mountain. This is called a peak. Okay, and this portion, this curve portion, this lowest portion, this is called a valley. Okay, so these peaks and valleys are important characteristics of a function. So when it comes to the second degree, you can say there is a valley here. This is a valley. This can also look like something like this. A second degree polynomial can also look like this. Now here we have a peak here. So a second degree polynomial can have either a peak or a valley. Now when it will have a peak or when it will have a valley, okay, or what will be the shapes of like this? So it can be like this, it can be much more narrower like this, or it can be like this, okay, flat. So it depends on the parameters that are associated with the equation. Say for example, for a straight line, I have two parameters m and c. Now if I draw a different straight line like this, say for example like this, so obviously you understand that this one and this one has two different m and two different c. Okay, similarly if you change the value of a, b and c, this shape will change. Okay, so these coefficients or parameters, whatever you say, this coefficient actually represent the curve, the shape of the curve. Okay, now so you have seen different degree of polynomial and you also know the their shapes. Let's take a look at it in the